Hey, you doing everyone? Greetings and welcome to episode 7 of Learning bAtari Basics. So what we're going to do today, instead of what I had originally planned, which was pretty much to finish up the series, we're going to do something I forgot completely about. And that is using paddle controllers in your bAtari basic programs. These paddle controllers here aren't at all official ones. They're ones I made up myself a couple of years back, but they work just fine. But the great thing about paddle controllers is that they give you a whole different style of gameplay. Instead of a joystick, a paddle can be used for a different type game completely. The other nice thing about these is that you can connect 2 paddles to each joy port or each controller port. So you can connect up to 4 paddles at a time, meaning that you can write games that 4 people can play simultaneously, which is pretty cool. But you need to keep a few things in mind if you're going to use paddles in your Atari games. And the first thing is really, as far as the Atari is concerned, a joystick is very different than a paddle. Now, I'm not talking about the way it looks, but a joystick connected to an Atari 2600 is interpreted as 5 buttons. A button for up, down, left and right, and a button for fire. And when these buttons are pressed, a digital signal is sent to the Atari and the processor knows kind of what to do, to move the character up, down, left or right or whatever. Paddles are completely different because they use analog signals, kind of variations of voltage. And these analog signals need to be interpreted by the riot chip inside in the Atari so that the riot chip's analog to digital converter can convert this analog signal into something useful that the processor can use, a digital signal. So straight away, it takes a little bit of processing power and it takes a little bit of time to do this conversion. So you kind of lose out a little bit. And actually, in order to use paddles with bAtari Basic, you have to give something up because of that. The thing you have to give up is one of your missiles. So all of a sudden, instead of having 5 objects on screen being your 2 sprites, your ball and 2 missiles, you're down to 4 objects on screen when you're using paddles. You've still got your 2 sprites, you've still got your ball, but you're losing missile 0. So you've only got 1 missile. But there is a kind of an upside. Now, just to say that if you want to use paddle controllers, there's something special you have to do before you start your program. I'll show you that right here. What you need to do is you need to set your kernel options to no blank lines and tap in read paddle. That's the first thing you need to do. Now, kernel options are a bunch of little options you can set to tell the bAtari compiler to compile your code in a certain way. We haven't covered these before. I'll be covering them a little bit in the next episode. But what we're doing is we're selecting the no blank lines kernel option. And what that pretty much does for us, apart from taking away our missile 0, is you'll remember any of the playfield pixels that we were using in the past. Like if we were drawing a playfield, they were always composed of horizontal bars with a little black space between them. Well, using no blank lines, it'll get rid of that little space. So we'll end up with a nice solid playfield area. So that's I suppose for losing our missile and using our paddles, that's a little extra that we gain. But this first program that I've written here, what it'll do is it'll put just a little bar down the bottom of the screen that we can move from left to right using the paddle. So I'll show you how this guy goes together right now. So as I explained before, if you want to use paddles with your bAtari Basic program, what you need to do is you need to set kernel options, no blank lines, read paddle. That's the first line. Then you're set to use paddles. Now, the way I've set up this program in the beginning is pretty much the same as we always do. I've defined player 0's position. So I'm setting player 0 to 80 on the y-axis. He's going to be rigid there. He can move anywhere he wants on the x-axis using the paddle, but he's going to be stuck at position 80 down here at the bottom of the screen on the y-axis. Then what I've done is I've opened my main loop. We're setting the background color, we're setting the player 0 color, and we're defining the shape of player 0. So it's going to be pretty much a brick here. And that's stuff we've done before. Then what I've got here is I've got current paddle equals 0. Now, you'll remember that up to 4 paddles can be connected to the Atari. So in order to differentiate between them, we can have current paddle equals anything from 0 to 3. so that we can say which paddle we want to use. Now, as we're only using one paddle in this particular example, our current paddle will always be 0. We're not going to worry about it. We just set our current paddle to 0, and that's that. The next line then is saying that player 0x, so player 0's x position, will equal paddle. So the value that the paddle is given. But then there's a little bit of maths here beside it. What we're doing is we've got the paddle position multiplied by 2 plus 1. And the reason for that is actually very simple. You'll remember that the full range of the x-axis when we were doing any of our programming in the past goes from 1 to 159. Well, the range of the paddles is from 0 to 77. So if we didn't have this little multiplied by 2 plus 1, the only range we would have when reading a paddle would be across half the screen, from 1 to 78, and not the rest. So what we need to do is we need to take the value that's been given by the paddle, multiply it by 2, and we add 1 to it so that we get the entire range of the x-axis. So that's the reason that that's defined like that. Then what we're doing is we're drawing our screen and we're looping back to main to do it all again. And when we execute that code, what we get is we get our little paddle here down the bottom of the screen, which can be moved to the right and the left using our paddle. Or in this case, because I'm using Stella, I'm using the mouse here. And you'll see that there's a little bit of overspill when I go over here because I haven't defined any restrictions on the x-axis. But that is pretty much how we set up a single paddle to be used in bAtari for a game. There's not an awful lot to it. Now, when it comes to writing games that use 2 or more paddles, things get a little bit more complicated, but not superly so. You'll see, again, we're setting our kernel options, no blank lines, and read paddle. But here what I'm after doing is I'm after sticking in a variable, and I'm after putting the value of 0 into it for the moment. Now, in this particular example, what I'm going to do is I'm going to put 2 sprites on screen. There's going to be one on the left-hand side, one on the right-hand side, and they're going to move up and down on the y-axis. So what I've done is I've kind of set their positions or locked their positions on the x-axis. Player 0 is going to be locked at position 10 on the x-axis, so he'll be able to go up and down here. And player 1 is locked at position 146 over here on the x-axis, so he can move up and down here, so they'll be opposing. Now, again, what I've done is I've opened my main loop. I'm setting the background color and then the player colors. Again, I'm defining the shapes of player 0 and player 1. And then what I'm doing is I've got p equals p plus 1. So I'm incrementing that variable that I had up on top that I put 0 in. So it's going to equal, well, under normal circumstances, it'd equal 1, 2, 3, 4 with each cycle. But what I've done straight away is I've kind of curtailed it. What I've done is I've got if p equals 3, then p equals 1. So what's going to happen is p is going to equal 1, 2, 1, 2, 1, 2. And the reason I've done that is because now we've got 2 players and we're using 2 paddles. So as only one paddle can be read in each cycle, we need to differentiate between which paddle is being read. So what I've done is I've put in a little condition here. So if p equals 1, then the current paddle will equal 0. So if p equals 1, the riot chip will look at paddle 0 and it will process its information. And then in the next line on that, player 0y equals paddle. That's what's happening. The value that's obtained from paddle 0 will be put towards where player 0 will be on the y-axis. And then for any cycles where p equals 2, the current paddle will be paddle 1. So it'll be reading the other paddle, and the value of paddle 1 will be put into player 1's y position. So it'll be able to read both paddles, although each other cycle it'll be reading each paddle. And then what I've done is I've put in a little bit of logic just to kind of keep them where they should be on the y-axis so they can't spill over or under. We're drawing the screen and we're looping back to main again. And when we run that code, what we get are our 2 paddles on opposing sides. And we can move this guy here with the mouse a little bit. And the other guy here, we can move as well. It's kind of difficult to do this paddle stuff using Stella, but it works great. Works great on the real hardware. But that's how you can set up to control 2 paddles. Now again, if you were using 4 paddles, you could set your P variable there to go from 1 to 2 to 3 to 4 and have it set up so that if P equals 1, it's reading the first paddle and so on and so forth right through all 4 paddles. And that is how you would use that. Okay, so each paddle has its own fire button. And this third example program that I want to show you is exactly the same as the very first one that I showed you. One little exception. I've got written down here, if joy 0 right, then colu bk equals colu bk plus 1. And that's actually because the fire buttons on paddles correspond to joystick directions. So the fire button for paddle 0 is actually joy 0 right. The fire button for paddle 1 is joy 0 left. The fire button for paddle 2 is joy 1 right, and the fire button for paddle 3 is joy 1 left. That's pretty much the way they're set up. So this is the only thing I've added in so that we could use that actual fire button on the paddle. And what we get when that guy is run is exactly the same as we had in the first program, even down to the little overspill. But when I press the button, the background color changes. So that's how we can use our fire buttons with paddles as well. So that's pretty much it. There's not a whole lot to use in paddles in your games with bAtari Basic. It really is quite easy to do. And what I decided to do was, because Stella doesn't really show it working great, and sometimes emulators work much better than real hardware. What I've done is I've written a small little example program that will use a paddle, and I'm going to show it to you right now on real hardware. And on top of that, what I've done is I've taken the code from that and I've copied and pasted it right down into the description below. So if you want to, you can cut that or copy it, and you can paste it into a word processor and compile it, use it, play around with it if you so wish. It's a great way to learn this kind of stuff. Just give me a second to set up and I'll show you my little example program running on real hardware. Okay, so you're ready for what is quite possibly maybe the most anticlimactic game demo in the world ever. But anyway, here we are, Atari, real cartridge in there. Here's my little paddle. When I press the button, look what we got on screen. And I can control this little paddle over here on the right hand side, make him move up and down. The fire button doesn't do anything apart from restarting the game. But what I've done is I've locked the other player over the other side. He's locked in to the Y position on the actual ball itself, and that's why he will always hit that ball and he'll always follow it no matter what else is happening. But that's it, just a simple little demo just to show that this code does indeed work with real hardware. And that's it for today's episode. Nice simple one. Paddles are really easy to use. They make for fantastic games. Would have been a pity not to cover it. So in the next episode, which probably will be the very last episode, what we're going to do is we're going to go over everything that I haven't gone over. We're going to look at kernel options. We're going to have a look at how to better use variables. We're going to have a look at bank switching, how it's used in bAtari Basic, and all that kind of stuff. We're only going to glide over it. And yeah, that will be pretty much it. So until that episode, we'll talk to you. Bye-bye.